Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem, construct string with repeat limit. The idea is we're given a string of characters, and I believe they are going to be lowercase a through z. And basically we want to take this set of characters, and let me make this example a little bit bigger because that's really what we're going to be focusing on. It's a pretty good example. Honestly, I think just working with this, we can pretty much arrive at the optimal solution. So we have these characters, and let's focus on the count of each character because that's kind of how we want to arrange the output. So we're given this input and we have this output. In some sense, we're sort of sorting this list, no pun intended, because they say return the lexicographically largest string. I definitely didn't pronounce that correctly. But in any case, what they say is it should be sorted basically in descending order. So not like A, B, C, but the opposite, starting with Z. So it makes sense that the Z's are here. Now, if it was that easy, if it was literally a sorting problem, we could actually solve this in pretty much linear time. Not n log n time, but linear time. Because what we would do is just count and sort. Count the number of characters. Since we know they're all lowercase a through z, that's 26 different characters. So you can do some kind of counting or bucket sort and solve this problem in linear time. But no, there's a catch, and that's what makes this problem interesting. There's actually a limit. We cannot have more than 3 consecutive characters that are the same. And that's why this is a good example. Because from the first example, it makes it clear that we can't do counting and sorting. Because clearly, if you count it, we have 2 z's, we have a single a, but we have c, there's 4 of them. And that's above the limit. So we cannot have 4, we can have at most 3 c characters. Okay, so how do we solve the problem? Just looking at this, just looking at what I have to work with, I probably want to do something greedy. I think that much isn't super difficult to arrive at. And what I mean specifically is we probably want to start with the z's. I mean, who cares what the counts of everything is? The first character should be the largest in the alphabet. But the hard part is the second step because, okay, I mean, if there were less than or equal to 3 of these guys, then fine, we're done with this. Just get rid of it. I mean, maybe this is stored in some kind of a hash map or some other data structure. Who knows? We're not really thinking about that just yet, but I'd be done with that guy. Okay, and then next I would say, okay, give me the next largest one. It looks like it's C right now. So, okay, I'm going to do the same thing. I want as many C's as I possibly can put here. So there's 4 of them. I can only put 3. So basically, of these 2 numbers, I took the minimum. Imagine if it was different. Imagine the previous example where we had 2 z's and 3 is the limit. Once again, we take the minimum. We add 2 z's to the beginning. That makes sense. So, okay, so we're here. We do that. We add 3 of these. And so now we have just a single one left. And this is where it gets kind of interesting. And it's honestly easier than you think. I'll go through like a quick state machine example to explain it. That might be overly theoretical for people, but if you've never taken like a computer science automata class, it might be useful for you. This is going to be a relatively simple one. So right now, we're in a situation where if we were just being greedy, if we were just being naively greedy, we'd want to take the largest lexicographical, largest alphabetical character, put C next, but we can't. We've reached the limit. So somehow we need to detect that. There's a different state going on. I guess I'll start with the state machine example earlier than I expected, just because I think it makes a ton of sense. When we're in this state, like this is one distinct state where what we want to do is just take the character that is the largest and add it. Add as many of them as we can. That's kind of the greedy step. And then the second step is this sort of awkward situation that we're in right now, where the most large character has already reached the limit. So in that case, we take the second largest character. That's it. Because now when you take the second largest and specifically just add a single occurrence of the second most frequent or second most large character, because even if we had 3, I guess that's the one bad thing about this example. There's only a single one of these, but imagine if it were 3, then we wouldn't want to add 3 occurrences of A. Would we? Because that's not the largest. I mean, think about this example for a second. I have this, and then I could have also made this string ZZ and then CCC. Imagine if there were like multiple A's. So I made a second A here, and then I had a C here. Is this string lexicographically larger, or if I had a single A here and then a C and then another A after? I know you probably can't read this super well, but this is lexicographically larger because we put one A here and then we did that. Now there's 3 of them here. So now this C is separated from this one. We only wanted a gap of 1. We did not need all the A's in here. So that's the idea. That's the second state. So in the second state, you take the second most frequent character and then you add it to the string. And so once you do that, then you end up basically back at state 1. So we did this, we did the second most frequent character, and now it's good. Now we're back at state 1, and now we just continue from here. So it's like a little circuit with just 2 steps. The nice thing about this solution is that it's pretty easy to implement if you know the data structure called the heap, because like I said, we want to be greedy. We always want to pick the largest one of these. And yeah, I guess it technically doesn't matter, just because, I mean, this will be of size 26. We could scan through it every single time, but heaps are just going to be a little bit more efficient. So that's how we're going to do it. Unfortunately, the heap solution is going to be kind of annoying to code up in Python just because like we don't have max heaps in Python. So working around like the character, the fact that we want to make these usually negative when we want to use a max heap in Python. So that's kind of what we'll do. And I'll show you guys how to do that. I actually had to learn it myself, or had to re-remember how to do it just because it doesn't come up super often. By the way, some of the tricks I'm going to show you right now, you can check out in this Python for Coding interviews course on Leetcode.io. If you are interested, there is this max heap problem. All these lessons like teach you all the tips and tricks of Python. You actually write code to learn, blah, blah, blah. If you're interested, check it out. Okay, so let's go ahead and code this up. And I realize I forgot to mention the time complexity. I'll probably just do that after we code it up. So the first thing we want to do is get the count of each character. I think that's obvious why it's important. We do need to have like some kind of mapping to know like if we've ran out of characters or whatnot. In Python, it's actually very easy to do that. There is something called a counter, which is basically a data structure. And sorry, I have to mention it just because it's relevant right now. I also teach that in this course as well. So counter and all the different variations of hash maps in Python. There's more than you might expect. But anyway, so this is just creating a hash map, counting all the characters, and then we want to do something called list comprehension because we want a list of pairs. So I'm going to do this for the character and the count pair in the hash map that we have up above, .items. We get these two, and I'm going to create a pair like this. I want the character and the count, but the problem is I want this to be the key of the heap. Specifically, we want the character to have the precedence, but like this character right now, it's going to be sorted from A through Z. By default, in Python, it's going to be a min heap, but we want it to be a max heap. So how do we do that? Unfortunately, Python makes it more annoying than most languages. In Java, you could probably write like a custom comparator, but here, what we're going to do is get the ASCII value of this. And if you're not sure what I just said, I said ASCII. If you're not familiar, I know some people don't have CS degrees, but I'm getting the ASCII value of this, which is some integer mapping. And so A might map to some number like 1, B maps to 2, Z maps to like 26 or something. These aren't the actual numbers, but they go in order. So what we want is this one to have the highest precedence, so we make it negative. So I'm going to add a negative sign right there. So that's what we're doing. I want this to be my max heap, and I'm going to turn it into a heap, adding like the sorted property to it like this, heap if I. So that's happening in linear time. And now we are going to basically run the simulation, the state machine that I mentioned earlier. So while the max heap is non-empty, we want to pop from the heap. That's step 1. That's easy enough. Step 2 is actually getting the values that we're unpacking. It's a pair of values, the character and the count. So we're unpacking that. We remember that this is actually an integer and it happens to be negative. So what we want to do to character is, first of all, let's get rid of the negative sign by adding another negative sign. And then to convert the ASCII value back in to like the actual character, the string representation, I think there's this function, char, or I don't know how to pronounce that, but that's what we want. And then what we want to say is, okay, result.append the current character. and this many of them, like this quantity of that character. But we know that might be too big. We want to take the minimum of that count and repeat limit. And I'll call that the current count, I guess, because I'm not super creative. And so that's the value we want to use here. Okay, now we're good. This is probably the hard part, at least in terms of implementation. And I just realized I forgot to declare my result. So I'm actually not going to make it a string. I'm going to make it an array because it's a little bit more efficient to build it this way. Strings are immutable. So we can just join all of those strings together, and that'll be a more efficient operation than doing a bunch of like string concatenations. So that's what this is doing here. And so next we want to say, okay, are there still some remaining? Because this is step one, like this is state one. And then state two is this. Are we in state two or not? I'm going to handle this with just an if statement because we can. There's only two of them. I mean, maybe there's a creative way with a loop. Maybe there's a way where we could reuse code, but is that really more simple? I mean, I know some people are all about that dry principle, but in practice, sometimes it just don't work. Don't be dogmatic. In this case, I think the solution I'm about to show you is just a bit more simple. So what I'm going to say right now, are there some left? Okay, the original count was this. Current count is what we actually added to the result. So if this is greater than 0, then we want to now pop from the heap again. Step 2, the second most frequent character. And so I'm going to call that here next character and next count. And next character, you know, we also need to do the conversion there. So I'm going to go ahead and do that. And so now we can go ahead and add a single occurrence of next character. So here we don't actually care about the count up above. Just go ahead and add a single one. But here's where an easy mistake can be made. We're expecting something to be in the heap, but it's not guaranteed. What if the heap was empty? What if we have a few occurrences of the most frequent character, but we actually don't have any other characters? For example, what if I gave you a string like this, s equals 4 a's, and the repeat limit is equal to 3? Well, we can't have more than 3 consecutive a's, so what would the output even look like in this case? I didn't mention it earlier, but in the problem description, they say that in a case like this, we can just return like AAA. We don't have to use all of the available characters to us. So that's what would happen. In a case like this, if I add a line of code here, another condition, and the max heap is non-empty, then we can basically handle this case. So that's the reason for this. And so now we used these characters. We used this character, and it looks like there's still some of them left. So let's add it back to the heap. Heap Q, heap push to the max heap, a pair. Remember that it is a pair. I probably could have saved, like here you can see I just took this character and then I reassigned it. Whoops, let's get rid of that. I got like the character. If I was smarter, I would probably just use a different variable name for both of these, but I'm very lazy. Don't be like me. So I'm just going to take this and given this character, I want the ASCII value of it, and I want to make it negative, just like we did up here. So that's what I'm going to do. Add a little negative sign. Since we used this many occurrences, so we just do this for the new count. So there you go. And don't forget that this character as well, there might still be some occurrences of that left. Let's go ahead and add that back to the heap as well. And I just realized I'm kind of mixing up my variables, but we're going to do this here. I'm really sorry. But here we'll also add the condition. Okay, if next count is greater than 1, go ahead and do this. And so now we'll just change the variable names around. This is the part where I just turned my brain off and I usually end up making some mistakes. So let's get rid of that. And then let's change this to a -1. We only used a single occurrence and the character is that one. So I think this is mostly it. I hope I don't have any bugs. If I do, it probably is related to how I'm using the negative sign. Let's give it a run. Okay, it was actually even more obvious. You can probably tell I'm a little tired, but thankfully that was the only one. So now you can see that this solution works and it's pretty efficient. And time complexity, I believe it's going to be linear because we are going to have to go through every character and then add those characters or substrings to the result. So that's n times the heap operation. Since the heap is only going to be up to 26 characters, I guess technically it's linear time. You could also say this times 26, or you could say, well, technically it'll be log 26 or log k, where k are like the distinct characters in this. If you found this helpful, check out Leetcode.io for a lot more. Thanks for watching, and I'll see you soon.